In Chapter 2, we begin to really start to program in earnest. We begin with uh, learning how to solve practical problems using programs. All right, we'll study things about variables and constants. We'll learn how to uh, ask the user for input from the keyboard. Right. Up to this point, we've simply done some create small programs and compile them and run them with Java. Uh, with this chapter, we're going to get a few more tools in our tool. So we're going to get a little slow pitch. We'll introduce variables very briefly. Uh, Later on in the chapter, we'll get into more detail. Uh, we will look at doing some more calculations. And finally, we'll end this section with talking about how to get input from the console. And in order to get input from the console, we'll have to use uh, what is named the scanner class. So let's start by getting some definitions out of the way. Uh, we all know that we have different types of problems that computers can solve, from as complex as being able to create a payroll check to keeping records in a general ledger to as we did last week, calculate the area of a circle. Right. So much of programming is more about your planning. The more time you spend planning, the more successful you will be in solving the problem using a programming language. And first thing you have to do is understand the problem, and then you start to create an algorithm, okay, which is simply a step-by-step that you design to solve the problem. Okay, uh, we one of the way you record your algorithm is with what we call pseudocode. And pseudocode is somewhat like English. It's not programming code. All right. So pseudocode is meant to be translated into a programming language at some point, but at the planning stage, we really don't need to know anything about a programming language. So it kind of the planning and the pseudocoding, the step-by-step that you design takes away all the complexities of a programming language. So any of these problems that we're going to be faced with this semester, you should be able to design a solution, an algorithm, as to how you should go about solving the problem. All right, some more definitions. One is we have to understand variables. And in this lesson, we're going to just very briefly touch on variables. Further lessons in the chapter will get into more detail. Okay, but as the definition implies, a variable holds data in memory, in random access memory for future use in our program. Okay, it has a name, which the programmer determines what that name should be. I require that all things that you name are meaningful. So we don't use names like X for a variable. X doesn't mean anything. If you want to have a variable that's going to represent miles traveled, then I would think you ought to name it miles or something similar to that. Okay. Also, variables have a data type, and we'll speak more of the data types in our next lesson. But a data type determines what kind of values the variable can hold, and as well as what can we do with the variable. So if we have a variable with the data type integer, right, we know that it can only hold whole numbers. It can't hold numbers with decimal points, because a decimal point number is not an integer. And if it's an integer, we can add, subtract, and multiply, and divide, etc. If the data type is string or text, right, such as hello Java, that is a text value. We can't do multiplication and division with it, right? But there may be other things we can do with the string data type. So some of the data types that are introduced here in this first lesson, one is the primitive data types. These are the data types that are automatically built into a programming language, and as such, those data types, or the names for those primitive data types that the programming language uses to identify them, are reserved words. So a primitive data type will be double. Another primitive data type would be int, int, representing an integer data type. We also have floating point data types, and those are data types that can hold decimal numbers. And one of the things you have to understand is that it's hard to mix and match these data types, and we'll talk about some of those rules. Okay. We learned about the print line method. Okay, and the print line method is part of the system class, and we're going to start using more classes in our programs. Okay, so what is a class? Well, in a simple form, the class, we have been writing classes and using those as programs. The reason we can use them as a program is that they have a main method, someplace to start executing code. Other types of classes don't have main methods, and they're really designed to be used by developers when they're building programs, and so they're already pre-coded modules to accomplish certain tasks. So imagine if you had to write the complex code that would display a message on the console every time you wanted to use that. How difficult it would be, and B, how boring it would be, because you would be writing the same code every time you wanted to display a message. So we have the system class, and the system class has the print line method in it that we use to display a message on the screen. Concatenation is something we'll learn about, and it is used to connect or join things together. So particularly we will use concatenation to join two text strings together to make one text string, or conceptually a sentence or a full name. So for example, if I had a variable name called first name and its value was Kenneth, and I had a variable and its name was last name and its value was Grenier, I could concatenate those those two variables together to build Kenneth Grenier as one string. The concatenation operator, as we will see, is the plus sign. So it looks as though we're adding and doing addition to a string. But if we're working with strings, it's really not addition. It's called concatenation. So let's take a look at solving a problem by developing an algorithm and expressing that algorithm using pseudocode, right? So the problem I'm faced with is I want to bake a cake. Now what do I have to do? What are the steps I have to follow to bake a cake? Well, I have to assemble my ingredients, get my ingredients out and lay them out on the table. I probably should preheat my oven so it's ready to bake the cake when I'm ready. Usually you need to prepare some type of cake pan. You need to grease it and flour it so the cake doesn't stick. Okay. So then I'm ready. I'll mix the ingredients together. I'll pour the ingredients into a pan, and I'll bake the cake until it's done. So that's a very simple algorithm. It's a step-by-step how to solve the problem. I want to bake a cake. If you can think of other steps that I should have had in there, I welcome that. I think I've got them all. And but that is not the cake. That is not, I don't have a cake when I'm done here. I have a plan on how to bake a cake. So when you have a problem to solve with your programming, okay, the plan is not your program. What I need to do now is I have to convert my pseudocode into something that, lets me get the job done. Okay, you see now I have converted my algorithm into a recipe. And I like to use this because a recipe is very much like a program. A program has data. A program manipulates data, right, to produce information. So there is a distinction between data and information. Information is data that has been processed, sorted, put into some type of context. All right. Data is simply raw facts. All right. So we have our ingredients, which is the data, and then you see the program instructions or the recipe instructions down the right side. If you recall, the algorithm kind of follows the algorithm: preheat the oven, grease the pan, mix the ingredients. All right. You see some things highlighted here. I want to point out that just as a program, like a program, this recipe has the same type of instruction constructs, all right, that I introduced, I think, the first day of class. That there are three types of constructs. There was sequence, selection, and iteration or looping. So if we look at the recipe, you follow the recipe step by step, one instruction after another. That is a sequence of instructions. Right? You have iteration or looping down there where the instruction says stir in the milk until batter is smooth. Well, we have to continue to stir. We stir over. We repeat the stir over, and we repeat the stir over until something tells us to stop. The batter is smooth. And then down at the bottom there is also another loop. We bake the cake until the cake springs back to the touch. So we don't stop baking it. We continue to bake it over and over again until it is done. All right, and the yellow highlighted ifs, those are selection structures. Okay, so an if is a way that we select statements that we want to execute. So if we're baking a cake, we're going to bake for 30 to 40 minutes. But if it's not a cake, we're going to bake for 20 to 25 minutes, a selection structure. So you can see in this simple recipe example that you have the model of a program, and we're not even talking about a programming language. Okay, if my little cake example made you hungry and you took a little food break, let's get back to the reality of Java and programming. So you're presented with a problem to compute the area of a circle. So we have a very simple algorithm here. All right, it's going to take 3 steps for me to complete this problem. First, I have to have some value for the radius of a circle. And then once I know the value, my next step would be, all right, I now can compute the area of the circle, which is radius squared times pi. And for what reason did I compute the area? All right, and have my program compute the area. I want it to tell me what that area is. So I want to display the value on the screen. So you see there's 3 separate little steps in this program. Right? The next slide, we're going to look at the program in total, and then we're going to go through and dissect the program and look at and analyze almost all the steps and explain them. So here's the completed program. Not, you know, it's well documented, right? And well commented, right? And the you can see through the comments where step 1 has been implemented from my algorithm, step 2, and step 3. So very, very straightforward. But let's examine this, you know, a little bit in more detail. Of course, we have our public class definition and our main method defined, and so we're ready to move on from there. All right, I removed some of the comments just to keep this fairly clean and easy to follow. So what is this first statement? Double radius. Right? Well, this is the way we declare or define, but you'll see the term declare, variables in Java. And my variable name is radius. Now I made that name up, or Dr. Liang, who wrote the textbook, made that name up. But notice that it is meaningful. And double says that this is a type of data item. The data type is double, and it can hold a decimal. So it's allocated a space in memory for the radius to be saved. So as far as we are concerned, you know, radius is what we will refer to when we want to set a value for radius or to retrieve. It's kind of like that on your calculator. You've got a memory button, and you can add things to memory, and you can recall things from memory. Well, we can add values to radius in memory, and then we can recall the value of radius from memory. Well, not much new going on here with the second statement we're looking at. Uh, Again, it's declaring a variable named area of data type double. So now we have two spaces in memory, two places, two slots in memory where we can store values for radius and area. Now notice they have no value yet. We've just gave them an address, kind of like uh, you have a house with an address, but you haven't got any tenants that have moved into the house. Nobody lives there yet. All right? Well, now things are starting to get a little bit more interesting. All right? The statement radius equals 20 is an assignment statement. All right? We use the equal sign as the assignment operator. And with an assignment operator, the value on the right hand of the side of the operator, on the right hand side of the equal sign, is assigned to radius. So as you can see, now our memory location now holds a value of 20. Right? So the assignment operator is very, very powerful. It is the way that we give variables in our program. I should have said that radius and area are variables because their values can change. All right. So the assignment operator is a way that we use to give value, all right, to our variables. Okay. Notice that area doesn't have any value. Well, now we have some real interesting things going on. All right. You should recognize this as an assignment statement. So area on the left side of the equal is going to be assigned the value from the right side of the equal. Now, when we did an assignment from radius, we simply used a literal, 20. Now we have an expression, an arithmetic calculation that we're going to go through. So we have the arithmetic of multiplying radius times radius, and then multiplying it by an estimation of pi. So once that calculation is all done, then that result will be assigned to area. Right? So the memory now, both our variables have a value. Radius is 20, all right, and area is 1256.36. Well, the last step of our algorithm was to display the value of area to the user. Now, just displaying the number 1256.636 is not very friendly. We should be telling the user, the person using this program, what does that number represent. So as you look at our print line statement, it begins with, hey, the area for a circle with a radius of, and then it has a plus sign, and then it says radius, and then it has another plus sign, and it says is, and it has another plus sign, and it says area. So what's going on here? Well, what's going on is that concatenation we talked about. Concatenation deals with building string data. So if we look at the command prompt on the right hand side, the output, you can see that what happened was the computer started printing the area for a circle of radius, right, 20. So it retrieved the value of radius, inserted it into our string that we're going to print. Then it added the word is, and then it retrieved the value of area from memory and inserted it into our string. So now we've got a very a user-friendly message so that our user understands what it is we have done. Okay, here's the look at the complete program again. Some of the comments added back in, but what do I do if I want to calculate the area of a circle with a different radius? Right. Well, I could open up the program in TextPad and change the value of radius from 20 to some new value, 30, 22, whatever. Okay, and so that's why we call it a variable, because we can vary the value of it. All right, but that's kind of awkward. Do you want your users to be calling you every time you need to calculate the area of a circle with a different radius, and then you'd have to come, okay, what's the radius? Change the program, compile the program, and then have your user run the program. That's very inefficient. So we're going to look next at how we can ask the user to enter a value from the keyboard, so that every time the user runs the program, they can run the program with a new value. A new value for rate. So before we develop the algorithm for our program, all right, just kind of I'd have to understand what the scanner class is, right? Remember, this is one of the classes that is part of the Java development kit, right? And so somebody else has wrote a class called scanner, and its purpose is to be able to get, or most of the time we say read, data from the standard input device, which is the keyboard. So somebody's already written that for us. And so what we have to do is learn how to use the scanner class. It's a program, all right? All right? Not a program that can run standalone, all right? But in this case, it's a class or a program that our program can use. And so we have to learn how to use that, okay? Another term to just be familiar with is prompt. And all a prompt is a message, all right, to the user, giving them instructions about what they should do next. Okay, so here's our algorithm. We have to create a scanner object. All right, this is object-oriented programming, and so we have to create an object of type scanner so we can use it. All right. And objects are created from classes that are in these libraries. Once we have the object, we need to ask our user to enter a value for the radius. So we need to prompt the user to enter a value for radius. Once we have prompted the user for radius, then we can read or get the value that the user has entered, so we can get a value for radius. Then we're ready to compute the area, and then we are ready to display the area. So our program has added a couple of steps here. Step 1 and Step 2 are a little bit new to us in terms of creating a scanner object and prompting the user to enter radius. Step 3, where we read the keyboard, the value that was entered on the keyboard, that was our set step in the previous program. That's where we set the value of radius, right? And then steps 4 and 5 are the same. Well, before we move into looking at the program, let's understand a little bit about uh, what 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 we have to do. Right? Remember the very first step we said we had to create a scanner object. Right? Step one, uh, that's what we're doing here. The syntax for it is scanner because that's the data type, and when we declare a variable, we always specify the data type first. So this is scanner. It's a class, so it's capitalized there. All right. Then input is a name I chose, uh, a meaningful name. All right. And then I have to specify that I'm creating a new scanner, and in parenthesis, all right, it's telling uh, the scanner class that I'm going to be using it uh, to retrieve input from the standard system input device, right? So that's how I create an object. As we move through the course, and there are more classes that we have to use, all right, uh, we have to create objects of that type so that we can use them, okay? Uh, as a class, all right, objects, classes have methods, and so under number 2 here, you see that there are several methods that the scanner class has, and we have to use the appropriate method for the type of data that we're expecting from the keyboard, right? And methods always have a parentheses paired at the end. Sometimes the parentheses are empty, and as we will learn later in the course, sometimes the parentheses have values in there. Well, we've already seen that when we did system.out.println. We had the parentheses, and within the parentheses, we had the message that we wanted to print. So that was a value that we were passing to the println method. So creating an object of type scanner is very easy. Okay, and then now that we have it created, then we will use our variable called input. All right, that's our object variable called input, and we will use that to read data from the keyboard. Okay, here's an abbreviated example, all right, of a program that might use the scanner class. All right, we first of all, I have defined a variable called double, or not called double, but a variable of data type double, and its name is DBL value. By convention, we name our variables with a lowercase, starting with lowercase. Right? Notice that we have convention that we start a class name with uppercase. Right? If I have like 2 words, like DBL value, double value, then I can upcase the second word. We kind of call this camel casing, and we'll see this again. Right? The next line, all right, creates, all right, my scanner object named input. Right? We saw that in the previous slide. Right? So I'm going to prompt the user with my system.out.print. I'm going to send a message to my user on the screen to enter a decimal value, because a double it can hold a decimal. Okay. Now you should have looked at that and said, well, did he make a mistake? Was that supposed to be print line, LN? Why did he just use system.out.print? Well, print is a different method, okay, of the system.out class. And when we used the system.out.println method, when our message was displayed on the screen, our cursor went to the next line. It was a carriage return line feed. It went to the next line. It's like hitting enter when you are typing your term paper, all right? And when you hit enter, it goes to the next line. In this case, when I use just print, all right, I don't go to the next line. So where's my cursor? My cursor is sitting right after my message. And that's why I've got a blank, a space after value colon a space, all right? So that the cursor is sitting right after that space. And now it's waiting for the next statement to be executed. I'm going to set the value of double value to, well, I have input dot next double parenthesis. Okay, so what is that? I'm calling my input object, right? That's my object that's of type scanner, and it says I want you to use the method called next double, right? And so you can read a double value from the keyboard, right? You'll see this. We've seen this with system.out.println. We see it now with my object input dot next double. This syntax of using the dot notation, right? We identify the object by name, input dot, and then we tell it which method we want to use, right? So you have to remember that dot notation when working with objects. Okay, here's the implementation of our program to get the radius from the keyboard and compute the area. So if you remember the steps in our algorithm, if you printed out the slides, you can kind of follow along with it. Okay. Well, line 1, import java.util.scanner is required because unlike system.out, the scanner class is not automatically part of our development environment. So I have to tell Java to go out to the library named java.util and bring in the code for the scanner class into my program. And so that's the very first step, and that's where you'll want to import all your classes in multiple lines there when we get more complicated programs. All right, it's even before we declare our class. Okay, lines 2 and 3 should be very familiar to you. All right, giving my creating my class definition and structuring the main method to start the program. Okay, line 4 is the creation of the input object of type scanner. Okay, I just the author simply calls it input. You could call this read keyboard or another name. Okay, input is not anything that is sacred, but that's what the author decided to call his scanner object. Right. The next line does that prompt. Right, so it sends a message to the screen and says, "Hey, enter the radius." Right, and then the cursor is just sitting there at the end of that sentence, at the end of that statement, blinking, waiting for the user to enter a number. All right, now the next line begins to get executed, line 6 gets executed, but it's just sitting there waiting. And what is it waiting for? It's waiting for the user to say, hey, I've entered a number. And how does the user tell the program that? It hits the enter. They hit the enter key. So once the enter key is hit, then the input object retrieves that double value and places that value in radius. Right? Step 7, we've seen that before. All right. It calculates the value of the area using that radius and places that value in area. So we got 2 assignment statements. 6 is an assignment statement. It assigns the value from what was entered on the keyboard to radius. 7 is an assignment statement. It assigns the value from our calculation to the variable area. And then 8 is the same information we had last time, but now we have a different radius, all right, and so we'll have a new area. There's a couple of things I should point out here. All right, if you recall the previous programs, we declared double radius and double area as some of the first statements in our main method, and that's where I like to see them done. All right, you have to declare a variable before you can use it. Okay, the author in this case has decided to declare the variable at the time he wanted to use it. So line 6 is doing a couple of things. It's declaring the variable, and then it's going out and getting the value from the keyboard and assigning it to the variable. And line 7 is somewhat similar to that. I don't think that's good structure. The next program we'll look at, I think I've modified to be more of a professional structure where we declare our variables right at the beginning of our method. Not at the beginning of our class, at the beginning of our method. One final thing I should point out is that line 8 down there, we should recognize that as a set of string that's being concatenated, right? That we're putting together, building our output message to the user. Notice that there's spaces before and after the word is. So that's so our output message will be readable, and the values for radius and area aren't just jammed up against the word is with no space. Let's look at one last program here, and this is a new problem. This is a problem where I want to compute the average of let's say 3 test scores. All right. So I have not developed or displayed the algorithm for this. All right, but it should be you should be able to figure out an algorithm that would follow along with this pretty easily. All right. Line 1, 2, and 3 we are familiar with. Again, we have to import our scanner every time we want to use a scanner class in a program. It has to be inputted. All right. Lines 4, 5, and 6, all right, are declaring my variables, 3 numbers that I want to compute the average of. All right. So they're of type double. All right. So whenever you declare a variable, you always specify the data type first, and then you give it a name. Right. So remember, these at 4, 5, and 6. I have 3 variable now. I have 3 memory locations, but they're empty. They have no values. They've simply been declared. And this is what I was talking about, good structure in the previous program. Okay. line 7, right? We've seen this now about three times, is creating my scanner object called input, right? And now line 8 is sending a prompt, and it's telling the user to enter 3 decimal numbers. Now I could be more specific, specifying that there should be a space between each number, but hopefully our user will understand that the only way to recognize a number is to start a new number after a space, right? And then 9, 10, and 11 have our 3 read statements, right? So it's the input scanner object is in line 9 is looking to read the first number entered on the line, and then it's looking to read the next number entered on the line, and then it's looking to read the third number, right? So when I'm done with line 9, 10, and 11, I have entered 3 numbers. Their values are in the variables named number 1, number 2, and number 3, right? And now I'm ready to compute the average, all right? Now, I didn't do a very good job because in line 13, I skipped 12 for some reason. In line 13, I'm declaring average and using it at the same time. If I had paid attention, I would have declared average up there by line 6 and so forth. Okay, very simple arithmetic statement. Add the 3 numbers together, divide by 3. Line 14, all right, sends my output message to the user saying the average of, and it's going to repeat, show number 1, then a space, number 2, and then a space, number 3, and a space, and is average, and then a space again. All right, so very, very straightforward. This program used the scanner object again, and it used it to retrieve more than one value before it was able to go ahead and do some processing.